Today in this video we will see nature of bending stress. Nature of bending stress is for simply supported beam. Consider one simply supported beam. Consider this simply supported beam. This is cross section of this beam and this is neutral axis of beam. If the beam does not loaded, then the beam will not bend as shown in this figure. And if the beam is loaded, simply supported beam, the beam will bend in such a way that it produces compressive stresses in the upper layer and tensile stresses in the lower layer. That means beam subjected to sagging bending like this. Upper side compressive stresses sigma c and lower side tensile stresses sigma t. And this is neutral axis. And lower side tensile stresses. Cross section is upper side compression, lower side tension. Here yc, yt. Distance between neutral axis to lower layer of tensile stresses and distance between neutral axis to upper compressive layer of tensile stresses. Here sigma c compressive stress at neutral axis stress is 0 and at tensile side sigma t. This is nature of bending stress for simply supported beam. Upper side compressive stresses and lower side tensile stresses. This is also simply supported beam, but this beam is with load sub W. That's why this beam bend, and with no load this beam bend no this beam not have any bending. Now next see cantilever beam. Whenever a cantilever beam is loaded, the beam will bend in such a way that it produces tensile stresses in the upper layer and compressive stresses in the lower layer. That means beam is subjected to hogging bending moment. For that, see, before loading, this cantilever beam is like this. That means before loading, this beam don't show any deflection or bending. And this is before loading. And after loading, after giving some load to this beam deflect like hogging. Load P is acting here, and this beam show tensile stresses on upper side sigma T and compressive stresses on lower side sigma C. Tensile stresses is this is neutral axis of this beam. And compressive stresses Arrows are like this support show compressive, so arrow like this, and this support show tensile viewer, so arrow like this tensile. Section for this will be neutral axis, upper side tensile, lower side compression, YT, YC, distance between neutral axis to extreme layer, and here stress sigma T at neutral axis 0 and at lower side sigma C. So this is for cantilever beam, nature of bending stresses, and this is for simply supported beam, nature of bending stresses. For simply supported beam, compressive stresses acts on upper side and tensile stresses acts on lower side. See this arrows, compressive stresses arrows for this support, compressive stresses compress this support, and in lower side this support tensile stresses give tension to this support. And for cantilever beam, see tensile stresses on upper side and compressive stresses on lower side. Thank you very much.